Hello Basement Programmers, and welcome to the basementprogrammer.com YouTube channel. This is Tom of basementprogrammer.com. It's November, which means that Microsoft has just released the latest version of .NET, in this case .NET 7. In this video, we're going to cover some really exciting new functionality for AWS Lambda that's become available in this release of .NET. As you may know, .NET 7 brings a new set of functionality called Native Ahead of Time Compilation, or Native AOT. Normally, when you build a .NET application, the final compilation to native code occurs at runtime. That means that your application can be more portable, but it means there's this just-in-time compilation process that happens as your code is being executed for the first time. As a result, the first time code is executed, there's a bit of a lag, while subsequent executions of your code happen very, very quickly. Now combine this with AWS Lambda. Lambda is going to grab your code when it's required, build an execution environment, and then launch your code into that environment. Now the mechanics of this are obviously more complicated, but at a high level it's kind of what happens. Once you have an execution environment ready and you've used it once, Lambda is going to keep that environment around for an indeterminate amount of time. As a result, we get what's commonly referred to as cold starts versus warm starts. Cold starts occur when that execution environment is new. There's a lot of things that happen during that cold start process, some of which are going to be the service and some of which are going to be your code. When you get a cold start and you're using .NET, you're going to be paying the penalty for that just-in-time compilation as your code is being executed for the first time. Warm starts happen when Lambda is recycling an execution environment that's already been used. When this happens, your code is already compiled and ready to execute, so things happen much faster. This is where native AOT comes in. With .NET 7's native AOT, you eliminate the need for your code to be just-in-time compiled at its first execution, and instead you compile the code into native binaries when you build your Lambda. Now this won't completely eliminate the cold start penalty, because there's still things that are going on as far as creating that build environment. However, it will improve the cold start time considerably. As you're going to see in this video, building native ahead of time compiled Lambda functions is extremely easy using the tools that AWS has already provided to you, available today. So let's dive in. Okay, so let's have a look at what's going on here with native AOT in Lambda. So first off, the prerequisites. You need to have .NET 7 installed. If you haven't installed it, go ahead and install it. If you have already installed a pre-release copy or a release candidate, you want to make sure you update to the release software that was published in November. We're going to have the .NET Tools for Lambda installed. You're going to have the Lambda Templates installed. And if you are not developing your Lambda functions on a system that's running Amazon Linux 2, then you need to have Docker installed. And of course, you're going to have an IDE of choice installed so you can actually edit your code. Installing the Lambda tools for .NET is easily done from the command line. You type in the first option here at the command line, so that's .NET tool install -- global amazon.lambda.tools. If you already have the Lambda tools installed, then you want to change the install option to be update, and run the command line to get the latest updated version of the Lambda tools. You want to make sure that your version of the Lambda tools is at least version 5.6.1, which is current as of this video. Installing the Lambda templates is also done from the command line as well. The same command works whether you are installing for the first time or you are updating your templates. Okay, so that's the .NET new -I amazon.lambda.templates. The current version as of this video is 6.7.0. Now the key item you're looking for in the list of templates is that lambda.native AOT option. Okay, so what's going to happen behind the scenes? Well, we're going to create and code out our project locally, just like we would any other Lambda development project for .NET. In my case, I'm going to use Visual Studio on my dev box. You can use any code editor that you want or any tools that you want. However, when it comes to actually building my Lambda function, the Lambda Tools is going to download an Amazon Linux 2 container image to my machine. And that's because the underlying infrastructure that hosts Lambda is running on Amazon Linux. It's then going to run a container on my machine. The tool will then send all of my source code into that container so it can be built natively on Amazon Linux 2. We'll then retrieve the build artifact, which is going to be a native binary image. We'll then package that native binary into what's called the Lambda provided runtime. So this is basically an empty Lambda runtime environment that gets just our binary installed into it. The result is then uploaded to AWS in order to execute natively. So there's no just-in-time compilation required. Okay, so let's jump into the code. Okay, so here we are on my development machine, and we're going to get started creating the native AOT compiled Lambda using .NET 7. Okay, so I'm going to create a new directory here and jump into that. And then I'm going to use the .NET command line to create my new project. So I'm going to do .NET new lambda.native AOT. Oops. And capitalization is important. So that's going to go, and that's going to grab a copy of the sample project and get it ready for us to use. Now, easiest thing to do here is to jump into Visual Studio and open a project or solution. And okay, so we've got local native AOT source, native AOT test. That's the project that was created. Okay, and we can have a look at the files that are set up for us. So first off, we've got this AWS Lambda Tools defaults.json. And that's going to allow us to set a bunch of defaults for our function and how it gets created. This is an information section here. There's a profile, so if you wanted to use a named profile, I'll leave that blank. There's a region directive, so if you wanted to deploy your Lambda function to a region other than your default, the one that's stored in your profile, you could specify it there. I'm going to leave it blank. My default profile is US East 2. Configuration release, the function runtime provided AL2. This is just going to specify what runtime the Lambda is going to use. Provided.al2 is that sort of generic clean runtime that doesn't have any of the other stuff like the .NET framework installed into it. And then obviously you've got your function memory size and your function timeout. Those are the values that govern how Lambda is going to be controlled. Function handler bootstrap, don't change that. You want it to remain bootstrap. And build parameters, those are the parameters that get passed to MS build. You got an rd.xml file, and this controls just how some directives that get passed to the build process. At this stage, you don't really want to change this at all. And you've got your function.cs file. So this is really the core of your Lambda. Now a couple things here. You've got your main function. Obviously, as we know, main is how your application starts. You don't want to change that code at all. You have your function handler. So this is your the actual code for your Lambda function. This is where all the all the magic happens as far as all your code that you want to execute at the time. And now down here we have this Lambda function JSON serializer context object. When we're using native AOT, everything gets compiled down to native code. So that means we have certain limitations. For example, we can't use reflection and we can't use code generation. So that means the serializers that would normally help us to take the serializers and deserializers, it would take the JSON and turn it into objects, or take our objects and serialize it back to JSON. Can't necessarily come into play. So what we would need to do if we're going to interact with any complex classes is add them here into the serializer. Now you can see the directive here, JSON serializer, serializable, type of, and then the object type, in this case string. If you wanted to interact with any other types of objects, you want to add an additional directive here. Just copy this line, change the object to what you need. And that would correspond here to your input parameter. So string for input and string for your function return. Now I'm not going to do that right now. First pass, I just want to make the simplest of Lambda functions so you can see how easy it is to build these native AOT functions. And we'll see about coming back later for a second pass and take advantage of these more complex classes. Okay, so I'm going to leave this function exactly as it is. You can see here all the Lambda function does is it accepts a string and it returns it and converts it to uppercase. Super simple, right? So the next thing I always do anytime I'm building any .NET project or any functionality, I'm going to do a build and just do a local build just to make sure it all compiles. So I want to make sure that all the template files downloaded properly, everything is good and in good shape. And you can see here, build succeeded. Great. Okay, so back at the command line here, okay, I've got my directory. I want to change into the source directory. Got a native. Okay, and I can see here I'm in the directory with the Lambda Tools and all my project files. Okay, so a couple things what I can do here. I can do .NET Lambda package. What this is going to do is this is actually going to go and it's going to grab the Lambda AL2 or Amazon Linux 2 runtime and download that to Docker. And then what it's going to do is it's going to build my function locally. So this gives me an idea that everything is good and in good working shape. Now obviously Docker is here. I do have Docker installed on my machine and it is running. And the other thing is you do have to make sure that Docker is set up to run Linux containers, not Windows containers. Okay, it's going to take a few minutes to finish up downloading. And then it's going to spin up that container for me. It's going to send all my source code over into that container and build it. You can see here, generating native code. Okay, and Lambda project successfully packaged. Great, so now what we've got here is we've got this native AOT test.zip file that contains all of the stuff that was built to deploy my Lambda function. It didn't actually get deployed because I just used the .NET Lambda package command. But I wanted to test to make sure everything was good. Now what I can do here is instead of doing .NET Lambda package, I can do .NET Lambda deploy function. It's going to do exactly the same thing, except it's going to add the step to actually publish the function into my account. Okay, now I'm going to be asked for the Lambda function name. Let's keep it simple here. Native AOT test will be the function name, so I can find it easy. And now it's going to ask me for a role. The role is the execution permissions that go with Lambda. Okay, so I'm going to create a new use option 2, create a new IAM role. going to give it the same name. Just add role to it, just to make it easy to find things in the console and clean up later. And now it's going to ask me for the IAM policy to attach. So I got a whole bunch of policies here. I'm going to choose 9, the AWS Lambda role, default policy for AWS Lambda service role. And I give it some very basic permissions. Now the Lambda command line is, with the .NET extensions to Lambda, is going to go and it's going to create that IAM role and allow that to propagate around regions. It does sometimes take a couple seconds. And now it's going to actually go through and deploy my Lambda function up into my account. This could take a few seconds to finish completion. Okay, new Lambda function created. So let's have a look in the AWS console. All right, you can see here Lambda functions. I was sitting in that before, just making sure everything was all clean. So let's do a refresh, and you can see native AOT test. Okay, so let's have a look at those details really quick. Function name, the function name that we gave it, native AOT test, package type zip. And that just means we've got a zip file as the main as deployment. And then we have custom runtime on Amazon Linux 2. So we've got .NET 7 application that we built, ready to go, and it's running natively on a custom Amazon Linux 2 runtime. Okay, and we can say do some tests. So let's create a little test event. Now, as you may recall, the function that I sent in is expecting a string. So we're just going to pass in a very simple string, hit test, click. Hit save. Okay, format the string correctly as a string, and then we're going to hit test, and you can see very, very quickly that execution occurred. So init duration took only 109 milliseconds, which is pretty good for a .NET Lambda running. And you can see the output successfully executed, and it passed. This is a test. So you can see setting up a native AOT, native ahead of time compiled function for Lambda, extremely easy and ready to go. Okay, so now building out a Lambda function that accepts a string and returns a string has some very limited utility value. So what we really want to do is to be able to build a Lambda function to be able to handle some other use cases and situations. So let's imagine, for example, that I want to build a Lambda function that can handle a processing an S3 object when it arrives in a bucket. Okay, we'll go to Visual Studio once again. First thing I want to do here is I want to go and manage my NuGet packages. Okay, and I want to search for Amazon Lambda .s3 events. Okay, and I want to add that, install that into my project. What that's going to do is it's going to give me some types that will allow us to receive an S3 event and process it in our Lambda function. Next thing I want to do is I want to change my event, so my event handler, so function handler here, I'm going to change this to be an S3 event object. Okay, so it's going to be input. Now obviously I can't just return input.toUpper because it's no longer a string. So what I do here is I want to say and I'm going to go input dot records 0 oops bucket. So what I'm going to do is I am going to return a string representation that's just going to be the URL for this object. So it's going to basically return s3 : / the bucket and then the object key. It just gives a it'll show us where the s3 object is. Okay, and then what I also need to do up here is back in my main function, I actually need to change the definition of this function here, okay, because it's accepting an S3 event rather than a string. Okay, sounds simple enough, right? We're going to receive an S3 event, we're going to do something with the objects, and we're going to return the value. Okay, so let's go back to our well, let's make sure this builds correctly first. Okay, no typos. And now I can do .NET Lambda okay, now it's going to go through it. It's going to retrieve. It's going to make sure we've got the the correct Docker image. It's going to throw my code in there and build it for me. Okay, it's going to ask me for the function name. I'm going to provide the function name, native AOT test. And so it then detects that we're really just updating the function code. So it's not going to ask me about creating the IAM role. And it's going to just take that packaged up Lambda function for the native compiled Lambda, push it up into my account. And you can see the code gets updated successfully. Okay, so what I want to do, I'm going to jump back into my AWS account, and once again, we're going to go in here to native test. I'm going to go to the test tab. Now, my function now doesn't expect a string; it expects an S3 event. So I'm going to go create new event. S3 test template. We're going to go down here. We're going to find the S3 put. Okay, and that's going to have a sample object here. We've got example bucket. We've got an object test key. Okay, I'm going to save. and I'm going to hit the test button. And what I'm going to find is that fails. Okay, so why did that fail? Let's have a look. We'll expand this and see there's a type error, JSON serialization. Now, if you remember when we first started talking about running native AOT Lambda functions, I mentioned that we can't use code generation, we can't use reflection. Okay, so that means we need to handle this, we need to handle that in our code. So what we need to do is jump back into Visual Studio. And what I always find is that we get a lot of red squigglies here. When we use the command line tools, they go away by rebuilding. Now, I mentioned before, the core to fixing that error is in defining our custom serializer. So what I'm going to do here is I'm going to copy this line, and I'm going to copy in the S3 event, because that's the serializer that we actually need to get to build and have available at runtime. Okay, so once again I'm going to save. I'm going to do a quick compile just to make sure everything is going good. Great. Minimize. And I'm going to go back and I'm going to redeploy my function. Once again, I'm going to ask the function name. It's going to provide the same function name so that the tool detects that it's really just an update for the existing code, and it's going to push it back up into my account. Okay. Function update complete. So let's go back into AWS account. Just going to do a quick refresh. Okay, once again we made our test. We've got the S3 event test set up there, and when I hit the test button, as you can see this time the execution result is successful. So we get a nice green bar, and if we expand here, we can actually see the key that's been returned by our code. So our code was going to go in and it was going to look at the values that were passed in. It was going to pass back the bucket, as we got there, sample bucket, test, and key. Okay, so as you can see, the creation of a .NET 7 Lambda today, available directly in your account with the tools that are available through the .NET command line, and you can create your own native compiled Lambda functions ready to go. So hopefully you found this video helpful, and you'll be able to use this to get started with .NET 7 on Lambda today. If you liked this video, if you thought it was helpful, please subscribe to my channel, and definitely you can provide feedback. As always, the email address is Tom, that's Tom, @basementprogrammer.com.